Hello. So the problem that we're going to be solving today is minimum replacements to sort the given array. So this is a classic interview problem that is asked in big tech companies like PayPal. You are given a zero indexed integer array nums. In one operation, you can replace any element of the array with two elements that sum to it. So the operation, I'll explain the operation that they're talking about. The operation is if you are given an array and you want to break a number down into two parts, that two parts x and y should be such that x plus y is always equal to the given number. So that means here it can be 2 3, it can be 4 1, right? So we have to break the number down in such a way that the broken down parts are the sum of the broken down parts is equal to the number itself. So we have to return the minimum number of operations that are used to make an array that is sorted is in non-decreasing, that is increasing order. So basically, to take their example, we have to see we have 3, 9 and 3. This is the example that they have given. We have to break 9 down in such a way that the broken down numbers are the sum of that 6 plus 3 is 9. Now you must ask, why just 6 plus 3 and not 5 and 4? Why not 7 and 2? So basically, here comes the concept that they have asked us minimum number of replacements, right? So essentially, if I would have taken 5 and 4 3, so I have to consider the last number as the maximum. Like, we have to build up to the last number, because if I break this number down into other parts, 2 and 1, essentially, then 1 1 1, so essentially my entire array will just become a bunch of ones, which I do not really want. So our underlying observation is that the rightmost or the previous element rightmost or the previous element is the maximum that we are building up to, building up to. So this is our assumption or observation also, you can say. This is the correct assumption or observation in order to make the number of replacements minimum. So here I broke this down into 6 3. Now I have to break 6 down in such a way that we have the sum of the two numbers as 6. Now again, the previous element, that is 3 here, the previous element is the maximum that we are building up to. So inside this array, we are building up to 3. That means again we will break this down into 3 3 3 3 and 3. So this is our answer. So this is the main crux of this was, okay, this is our Bible, this is our Bhagavad Gita, this is our Quran, this is our everything. This is our main assumption that we are here. So let's just take a very simple example. A simple example would be 1 2 9 11 3 4. So here we have two ways. We can either go left to right or we can go right to left. Let's just start by going left to right, because that's just iterating an array comes to us always in the left to right order. We always do that. That is just how our muscle memory is made. So here how do we start? Basically, in order to check the increasing property, we check if the previous element is smaller. So we check 1, previous, nothing in previous, so this is the first element, leave it as is. 2, greater than 1, yes. 9, greater than 2, yes. 11 greater than 9. Yes. 3 greater than 11. No. 3 is not greater than 11. So now we have to, this is the element that is breaking down the increasing order. Okay. So here we break 11 down. We break 11 down into 1, 2, 9, something, 3 and 4. So from this assumption that we have, we break this down into 3 and 8. Now we go behind again because 8 is the one that is breaking the increasing order. Then we go 1, 2, 9, again 3, 3, 3, 4, and we have 5. Now 5 is the one breaking down the increasing order. So essentially we are breaking 11 down into such a way that we break 5 down into then 3 and 2. So we have 2 plus 3 plus 3 plus 3. So now we will not be breaking down 2 here. Why are we not breaking down 2? Because 2 is the minimum number. Because essentially in the end, remove this for now. In the end, in order to make you understand, 2, 2, 2, 3, 3, 3, 3, 4. Now in the end, this 2 is a previous number. Sorry. Ek extra aa gaya. Anyways, so this 2, I think there is an extra 2 here. Anyways, but that 2 will become the previous element. That 2 will become the previous element. To the next number here. So we have to maximize the 2. So if we are dividing 11 into 2, 3, 3 and 3, we have 4 places here. And we need this 2 to be maximum. 2 is our minimum in this, but we should maximize the minimum number so that the next number. So like if this was something, so let's just take another example here. We'll be dividing 13 obviously. So 13, let's say we have 4 placeholders. Again, how are we calculating those placeholders? We have 4 placeholders here and we need to fill. We can fill it as, because here it is 4, so we'll be going like, let's just go like 4 plus 9, then we have 4 plus 4 plus 5, then we have 4 plus 4 plus 4 plus 1. We'll have that. So like again, if I am saying I have 4 placeholders, I have 1, 4, 4, 4 here. This would be our previous element for the next one, right? This would be that. So we need to maximize this. So that the next number does not take multiple, it does not break down more. So we need to maximize this. So firstly, in order to calculate the number of places, so that this is a basic observation that we made, कि every time that we are breaking it down into, we are breaking 13 and 11 down into 4 observations, 4 parts, I must say. So how do we calculate that part? Basically the formula for that is math.ceil of the current element divided by the previous element, right? So now where did this come from? Where did this come from? So basically if you see, our number given was 11, our number given was 13. If I divide it by the previous element, that here it was 3 and here it was 4. What is 11 divided by 3? 11 divided by 3. It is 3.66. That means we will need the ceiling of this. Like I cannot have 1 number, 2 number, 3 number and 0.6 number. I cannot have that, right? We are using integers, we are using whole numbers. So we'll need one more value in order to fill this. Again here, what is 13 divided by 4? It is 3.25. 3.25. So we'll need 4 here, that is 4 digits in order to fill that, right? If we had 17 divided by 4, we had to divide 17 by 4. 17 by 4. So the answer to this was 4.25. So we will need 5 digits to fill that. So basically that comes from this key. We cannot essentially have 0.25 whole number. So we just have to take the ceiling of that, right? So it's like dividing sweets amongst kids. We will always need a sweet extra if we have less sweets for the extra kid. So basically, so let's just assume these empty places. Let's just assume these empty places as placeholders where numbers can be filled. Where numbers can be filled. Now, where numbers can be filled. Now, essentially, we need the maximum minimum number. Now here 1 was not, we could have done this like 2 3 3 3 also, right? Oh no, sorry. This was for 11. We could have broken down 13 into 4 3 3 3. Is this right? Yeah, this is right. Anyways, so we can, so here our minimum number is the maximum. Here our minimum number is the maximum. Our minimum number is the maximum here. So how do we get that? How do we get that? How do we get the minimum maximum number? Right? How do we get the minimum maximum number? How do we get the minimum maximum number? Now, let's take the example of 11. What was 11? Again, 4 places, and we had 3, 3, 3 and 2. We had 3, 3, 3 and 2. Here, can we break this down further? No. Can we break this down further? No. No, right? We cannot. So what is our minimum maximum number? Our minimum maximum number essentially is the whole division. So let's just assume that this 13 was something that is divisible by 4. Something that is divisible by 4. This 13 was something that is divisible by 4. So 12 is the most closest, so that will 3. So we fill these places with 3, 3, 3, 3. Right? And now, what is the remainder? The remainder was 1 because we need 13, right? So we placed a 4 here. We added that remainder here. If my remainder was 2, I would have added the remainder 1 1 karke here, right? So essentially that is how we are going to be getting the maximum. Our maximum number would be, our maximum minimum number would be the whole division, where we do not consider the minimum, by the number of parts. So for 11 divided by 4, what was 11 divided by 4? 2. We get 2 point something, but we are doing whole division, so we do not consider the remainder. So here my answer was 2. So my minimum is this, right? So that is how we get the minimum number. So basically, if we are observing all of this, so essentially our work becomes easy because we are just counting the number of operations that we are doing. So if we are dividing a number into 4 parts, the number of operations that we are essentially doing, the number of operations that we are essentially doing is number of parts minus 1, number of parts minus 1, and then we're going down and we're changing the previous number to the current number divided by the number of parts, right? So let's say in my example, what was my example? 1, 2, 9, 13 and 4 and 4. So we traverse from here, we come to 13. What do? We do 13. We break this down in how many parts? Math.ceil of 13 divided by the prev value. Here our prev, my prev is this by 4. So I get the answer as 4. So we break this down into 4 values. That means my parts, number of parts is equal to 4. That means the operations, total operations that I am gonna be doing will be increased by parts minus 1. And my prev value would be nothing but the current number, that is 13, current number divided by the number of parts. That means when I divide 13 into 4 parts with the given operation, we would have something here. We are not really interested in knowing what's here, but we are interested in knowing when I go from this 13, when I go to 9, what would be my prev ka value? So essentially my prev ka value that I calculated here was 2. My prev becomes 2 and my current value becomes 9. And the number of operations added was parts minus 1, that is 3. 3 operations I did, and I solved the example up as well. So you could have clearly seen that the number of operations was parts minus 1, that was 3. And again we do the same thing to 9. What is 9? 9 ka previous value is 2. So the number of parts, 9.9 divided by 2 is 4.5, and the ceil is 5. So we divide 5 into 5 parts. The number of operations that were added, first it was 3. Initially operations were 0, then it changed to 3. Now we added 4 to 3, because 5 minus 1 is equal to 4. So we added 4 to 3, we got 7. And what is our previous value? What would be our new prev? Our new prev would essentially be current divided by 5. And here my answer would be 1. So I divided 9 into 5 parts, where my maximum minimum value I hope you all understand that maximum minimum value, what essentially that is. I have explained it very well. So maximum minimum value would again be 1. My maximum minimum value would again be 1. Then I do the same thing here. So basically I divided 9 into 5 parts, where this was 1. This became my prev, this became my cur. Then I do the same thing here. Essentially we have to divide this into 1 and 1. So that is a total number of 1 operation. And I think the answer would be 8. This is what we have to return. So the coding to this is pretty simple. So let's just code it up now. Basically, what did we want? Firstly, so we want int n is equal to nums.length. I'm doing Java, by the way. Then our return type is long, so we have long ans is equal to 0. Ans is equal to the total observations. So total observations, or just let's name it as ans for simplicity. Then long previous value is equal to nums at n minus 1, because what was the theory? Our assumption was rightmost or the previous element is the maximum that we are building up to. So our previous value would be 1. Then I start from int I is equal to n minus 2. I is greater than equal to 0. I minus minus. We are going down the array, and then our long cur is equal to nums at I. Our current value, we get our current value. So if my current is greater than the prev value, my number of parts would essentially be math.ceil of current divided by prev. This would be my number of values. But now the catch in Java is that this is an integer or a long number. So essentially the division of this would again give me a long or an integer. It would not be. So before the ceil function is occurring, I would be calculating this value, and hence I need to change it to double. I need to typecast current to double so that the answer comes in points, and then we apply ceil to it, and then convert it into long back again. Then that is just a Java issue. We can manually also do the sealing thing, but we have libraries, why not use them? If we want more efficient code, we can do manually the sealing property whole thing. But right now let's just focus on problem solving. So answer plus equals to parts minus 1, because parts minus 1 was our answer. Like the total, we are adding the number of observations that took to break down completely the given current element of the array that we are at. So, and we change our prev to current minus number of parts, divide by number of parts, and else if not parts, prev is equal to cur. And then we finally return our answer. First we run the test cases to see if there are any syntax errors, and then boom, our test cases were accepted. Now we submit, and hopefully it gets accepted. We got accepted, and yes, our time complexity was the same, our approach was the same. But if you see the people with faster things, all they've done is they've replaced the math.ceil manually. But since I was focusing on problem solving, so it just does not really matter to me, at least. I'm also a student. Anyways, thank you so much.